So today we're talking about Chapter 2, Section 2. As promised, we'll be talking about circles. Alright, so from the top, a circle is defined by the set of all points x, y. Okay, so to be these points x, y, in the Cartesian plane that are a fixed distance r from a fixed point hk. So again, all that, if we unpack that entire sentence, a circle is a set of all points x, y, so basically just points, okay? In a Cartesian plane that are fixed distance r, so that a fixed distance, so in this particular case, this would be the fixed distance, so this distance out, and all the points that are a fixed distance from there, so that would be our radius, right? From a fixed point hk. So hk moving forward, that's going to denote the center of our circles. Okay. The fixed distance r is called the radius of the circle, and the fixed point hk is called the center. Alrighty, let's move it down here now. Okay, so the standard form of an equation of a circle with center hk. So again, the center is denoted by the letters h and k, and radius r is x minus h quantity squared plus y minus k quantity squared plus r squared. Yes, this is going to be something you need to memorize as well, so make sure you put a star by that. The standard form of an equation of a circle centered at the origin with radius r is x squared plus y squared is equal to r squared, which makes sense because if we're at the origin, my coordinates at the origin are 0, 0, so let's just put in 0 here and 0 here. Well, x minus 0 is just 0, or x minus 0 is just x, and then x squared plus y minus 0 is just y, because there's y squared. Of course, that's what we see here. Okay. So these are the basics of a circle. I mean, realistically, we can just go ahead and just snip this whole thing. There's not much, there's not any computation involved here. So I'll just go ahead and snip the solution along with it. So starting from the top, we need to find the standard form of the equation of a circle whose center is -2, 3, and with radius 6. Alright, so I'll take it back. There might be a little bit to unpack here, because I don't think I fully explained this. Okay, so let's actually fully explain this real fast. All right, so notice that the center is HK. Okay, it's not negative; it's just straight up HK. All right. Alrighty, so notice how the signs down here are a negative h and a negative k. Okay, so it's x minus h plus y minus k. All right, so what this is telling us is we're going to be taking the opposite sign. Okay, whenever we transition between what the center actually is, which is this, and putting it into the formula, which is this, we're going to be changing the sign. Okay, so let's now that we got that out of the way, let's try to do this again. And honestly, I probably shouldn't, in hindsight, I probably shouldn't have just snipped the solution, but we're here now. Alrighty, so if the center is at -2, +3, okay, well then, you know what, let's just go ahead and delete that. Turns out, I did want to do some computation. Alrighty, there we go. Alright, so we need to recall the formula, right? The formula was x minus h quantity squared plus y minus k quantity squared, and that's equal to the radius squared. Okay, so again, looking up here, we're looking at the opposite sign of -2 and a +3, and the opposite sign would be, of course, it would be +2 and a -3. So what we're going to do is we're going to come down here, we're going to write x, and then it's a minus minus 2. Okay, so minus negative 2. So we're going to do it this way first, right? And then y minus, well, that's going to be minus a 3. And that's going to be equal to r squared. And the r is 6, so 6 squared. Okay. Now, realistically, you could have, you can, if you want to, basically skip what I wrote in blue and go and jump straight to this kind of thought process. Okay, so here we go. X, we take the opposite sign of negative 2, so negative 2, the opposite sign is positive 2. Oh, forgot to put my square there. And it's squared plus, and then y, what's the opposite sign of positive 3? That's going to be negative 3. Good. And then r squared, so my r is 6, so 6 squared is 36. Okay, so you could essentially just skip writing the blue and jump straight to the green, but at the same time, starting out, I don't think you should, but it's still an option for you. Okay, but obviously, transitioning from the blue to the green, all you basically have to do is just clear these parentheses here. I probably should draw another color. Clear these parentheses here, as well as square the 6, and then you'll get to what's in the green. Okay, not abundantly difficult. It does get harder though, so don't you worry. Alright, so this reads, find the standard form of the equation of a circle whose center is 0, 6, and that passes through the point 4, 2. Oh, well, what do we do here? All right, so this is not going to be fun. We're going to have to think a little bit. All right, so let's think. All right, so first of all, let's draw us a Cartesian. So 0, 6, 4, 2. Okay, so that's fun. Let's draw us a Cartesian plane. Okay, and the standard form of the equation of a circle whose center, the center is about up here. Okay, it's about here. The center at 0, 6. There we go. All right, and it passes to the point 4, 2. So 4, 2 might be somewhere around here. Okay, something like that. And then of course, the circle looks something like this. Okay. All right, so we need to find the equation of that. So how do I find the equation of that? Okay, so first of all, what I need to do is, well, I don't want to say first of all, but it's helpful to know the radius, right? Because my equation, my circle equation has an r squared, okay? So that seems like a pretty good place to start because we're told the center, okay? So in our equation, let's go ahead and rewrite it again. X minus h quantity squared plus y minus k quantity squared is equal to r squared. And let's just go ahead and fill in these blanks here, okay? So we can go ahead and fill this in as, x. Well, okay, well, x minus 0 is just going to be x, okay? So this turns into x squared plus, and then y minus 6, okay? So y minus 6 quantity squared. And that's going to be equal to r squared. Okay, now r is the only thing we don't know. So how do we figure out r? Okay, well, if you recall, r is just this distance, right? Well, lucky for us, we have a distance formula. Okay, so we're going to say the distance, okay, but the distance between, I mean, we could write between C and, that point, but it doesn't really matter, I guess, okay? But the distance is equal to, if you recall, it's going to be the difference in the x's squared and the difference in the y's squared. Okay, so let's go ahead and let this be 0.1 and this be 0.2. Okay, so let's say 4 minus 0, right, the difference in x's, quantity squared, plus the difference in y's, 2 minus 6, quantity squared. Okay, and then this turns into 4 squared plus 4 squared, right? So that'd be the square root of 32, right? And now that is the distance. Okay, well, if that's the distance, that's also simultaneously the radius, right? I mean, that is the definition of a radius. So what we're going to end up with is an equation that is x squared plus y minus 6 quantity squared. It's going to be equal to, the square root of 32 squared. Okay. Well, what do we know about squaring something that's in a square root? Well, they cancel, right? It just basically cancels with itself. So it just becomes simply a 32. Okay, and that's it. We had to think a little bit about that. Kind of drawing the picture does help, right? But we had to think about that. Okay, well we have everything needed for our circle equation. Okay, so we have h. We need an h, k, and a radius. We were given the h and the k, so we just had to figure out the radius, right? And I'm pretty sure the next example also makes us have to use our brain as well, just a little bit. Okay, so same procedure. We're going to think about this. Alrighty, so this reads, find the standard form of an equation of a circle that contains endpoints of a diameter at -4, -3, and 2, -1. What in the world? Okay, so we're not given the center, so we don't have h or k, and we're not given the radius, so we don't have r. So we're going to have to figure out both the center and the radius. Okay, so let's go ahead and just kind of envision what's being asked here. Okay, so the point -4, -3 could be somewhere around like -4, about something like right here. Okay, so we'll call this -4, -3. Again, it doesn't have to be perfect. All I'm trying to do right now is, oh my goodness. Okay, that's going to be -4, -3. We'll underline that in red. All right, and then blue 2, 1. So over 2, 2, -1 over 2, down 1. So about right here. Oh my goodness. Okay, so hopefully my pen doesn't, do that thing today. Alrighty, so this is our circle, okay? These are endpoints of a diameter, meaning, if I were to connect, excuse me, still having a little bit of sneezing fits. These are the endpoints of a diameter, so it looks something like this. All right, so if these are the endpoints of the diameter, then obviously this point right here between them is going to be the radius, right? Because they are the endpoints of the diameter. Okay, well, how do we figure out that point in the middle? Well, that kind of gave it away, right? The point in the middle, we're going to use the midpoint formula. Okay, so what was the midpoint formula? Well, if you recall, it was basically taking the x's and divide by 2, and then taking the y's and divide by 2. So I conveniently, went ahead and color coordinated. So let's do this. Let's go ahead and do this. Divide by 2. Divide by 2. Okay. So the difference in my x's, so we've got -4. And then, no, I'm sorry, not difference in my x's, the sum of my x's. -4 plus 2, let's do this, plus 2. And then the difference of my y's, which is a -3, and then a -1. Okay, so this becomes my center. Okay, so -4 plus a positive 2 is a -2. -2 divided by 2 is going to be a -1. And then -3 minus 1 is -4. -4 divided by 2 is a -2. Okay, so this point right here is -1, -2, and obviously it would, right? But you can kind of see that, right? Because it looks like we're going over about 1 and then going down about 2, so that makes sense. So this becomes my center. So that part's taken care of. So let's go ahead and Circle that and put a C over it for center. Okay. Well, now we have my center, which is here, and then same we're basically where we're at on the last problem. We need to figure out my radius. Okay. Well, my radius is going to be my center to either of these 2 points. It doesn't matter which point, right? Because it's going to be the same distance to either. I like to not deal with negative signs, just like you. Okay. So what I'm going to do is I'm going to choose one of these that has the least amount of negatives. And honestly, I mean, difference between 1 negative and 2 negative, whatever, not a big deal. Okay, but let's go ahead and do this. So we're going to say the distance is going to be equal to, and again, I'm just going to, it's the difference in x's squared plus the difference in y's, right? So I'm going to go ahead and start off and put the center here. So it's a -1, and then it's going to be minus, right? Excuse me, minus, and then I'm choosing this point, so it's going to be -2. -1 minus 2 quantity squared plus, and the difference in my y's is going to be -2, and then minus a -1 quantity squared. Okay, and it is important, and negative signs always got me as a student, and they will sometimes trip me up as an instructor as well. So that's why I like to put things in parentheses, just so I can, cover my bases, right? Right, anyways, moving on. -1 minus 2 is a -3. -3 squared is a 9. So we've got a 9 over here. And then we have a -2 minus a -1, so it becomes a +1. So -2 plus 1 is a -1. -1 squared is 1. So we've got 9 plus 1, which is equal to 10. So we have the square root of 10. Okay. So now we can kind of polish off our formula. My formula for the circle is going to be x, and again minus h, so it's going to be plus 1, okay, because it's the opposite, quantity squared, plus y, and then plus 2 quantity squared, again because we're doing the opposite of those. Okay, and that's going to be equal to, and again, same as the previous problem, it's going to be the square root of 10. That's the radius. Again, remember r squared, that's the formula. Well, again, the square root of 10 squared is just simply 10. And so this is our final solution. Okay. And, excuse me, the last two problems, as far as, trying to think your way through circles, honestly, I feel like that's the most you're going to get. Yeah, there's not too many other ways you can kind of word circle problems to make you think about stuff. So these last two examples are really basically about it. But you have to know which is which. When you need to find the radius, when you need to find the diameter. When you need to find the radius, when you need to find the center, and things like that. But we have those tools that we learned in the last lecture. Okay, now we're going to get to something that I know you're not going to like. No, I'm not. Not yet. Not yet. Let's see. Yeah, we're going to put these in the notes. We are basically about to find, excuse me, we're basically just about to find the intercepts, okay? And of course, we've been able to find the intercepts on our polynomials, and it's no different finding intercepts for circles. Okay, well that puts the solution in there. I don't want the solution. Okay, so this reads, find the center and the radius and sketch the graph of the circle. Okay, well, what is the radius here? Okay, well again, if we can do this easily. We'll do the easy part first, right? Well, the radius, okay, that 9 is basically r squared, right? So, because again, the formula, let me actually write this out. Okay, and then we're going to write the problem underneath it. Oops, not h. The actual problem is -1. We're not even doing intercepts yet. All right, well, getting a little bit ahead of myself, but that's fine. Okay. Well, the center, okay, the center is again going to be, we're looking at the opposite of those, right? So the opposite of -1 is 1, and the opposite of +2 is -2. So my center is going to be at 1, -2. Okay, and then my radius, again, my radius in the formula is r squared. So this is essentially 3 squared, right? Let's not put a, let's put an actual equal sign. That's essentially 3 squared, right? So the radius here will be 3. And the way we just sketch this, obviously we just go on your homework. What you're going to do is you're going to go to this, you're going to pin the center, and then you're going to use the circle tool, and you're just going to go out 3 units, okay? I mean, you can either go up 3 units, right 3 units, down 3 units, or left 3 units. It doesn't matter. It's going to uniformly expand that circle for you, and it's very intuitive. So you're gonna know whenever you do it. So I'm just gonna go ahead and instead of graphing it freehand, I'll just post it here. Again, on the homework, you're going to click on the circle tool. You're going to pin the center. 1, -2, and then you're just going to drag the radius out, and excuse me, and you're either going to go up 3, left 3, right 3, or down 3. It's your prerogative, doesn't matter, okay? But you'll know your radius, so you will drag it accordingly. Okay. Now maybe we might go to the intercepts. Oh wait, did I ask for intercepts? It did. Okay, sorry. So apparently this has got me unable to read. All right, so let's go ahead and find the intercepts. New page. Yeah. Okay. So we're going to find the X and Y intercepts, and so I know I thought we were talking about intercepts. So if you recall, we said if we want to find the x-intercepts, we set y equal to 0. If we want to find the y-intercepts, we set x equal to 0, right? So let's start with the x-intercepts. So the x-intercepts, okay, so we set y equal to 0, so it's going to be x minus 1 quantity squared plus, let's just go ahead and, well, no, let's not. And we'll just go and plug 0 in for y. Okay, well, we're going to do just a little bit of mental math to save some space here. So the left side becomes x minus 1 quantity squared. All right, so looking here, 0 plus 2 is 2, 2 squared is 4, and we're going to subtract 4 from both sides, so we're going to end up with x minus 1 quantity squared is equal to 5, okay, because I'm subtracting 4 from both sides. Okay, and then what we're going to do is we're going to take the square root of both sides. Okay, so taking the square root of both sides, so we're going to have x minus 1 is equal to plus or minus the square root of 5. And then we're going to add 1 to both sides, so we're going to end up with my x-intercepts are 1 plus or minus the square root of 5. And I don't really know what that is off the top of my head. 1, we'll just do plus the square root of 5 real fast. It's 3.23. And if we were to, let's go ahead and snip the graph again. Put it down here a little bit out of the way. Excuse me. And if we were to look at the x-intercepts, one of them is indeed right around, right here is right around 3.23. Okay, and if that was 1 plus the square root of 5, 1 minus the square root of 5 is negative 1.23. So again, negative 1.23 is right here. Okay, so makes sense. And now my y-intercepts, we have same procedure. Well, not the same, but computationally, right? We're going to put a 0 in for x. So let's go ahead and just do negative 1 squared. Okay, negative negative 1 quantity squared plus y plus 2 quantity squared. That's equal to 9. And then we can probably fit in one more. So negative 1 squared is is 1. And then we subtract 1 from both sides. So we're going to have y plus 2 quantity squared. And that's going to be equal to, and again, we subtract 1 from both sides. So it's going to be equal to 8. Right? And then continuing on, if we take the square root of both sides, we're going to have y plus 2 is equal to plus or minus the square root of 8. And of course, we can fix that up, but we won't right now. That's going to be equal to y is equal to negative 2 plus or minus the square root of 8. Okay, and of course, that intercept being negative 2 plus the square root of 8, which is 0.82. And again, I mean, all these make sense, right? But I mean, and this is down here is going to be, you know, something very close to 5, but not be 5. But that's all we do. It's the same procedures that we've seen before, finding X and Y intercepts. Doing the circle is no different. And I believe, let's double check. So we found the center, the radius. We didn't actually sketch because I said, guys, it's easier if I just snipped it. And then also find intercepts. So we did do all that. So I did do everything that time. Okay. So now bad things are about to happen. Okay, let me see. Yeah. So this is where I'm probably about to lose you. I know because nobody likes to complete the square. One second. Okay, so here we go. From the top, as you can see from example 4, if the equation of a circle is in standard form, it's not too difficult to determine the center and the radius. Okay, now that's obvious because, well, I mean, if it's in our standard form, it's pretty much written out for us, right? So looking here, you know, we know that my center is negative 3, positive 1. My radius would be the square root of 49, which is 7. Okay, so that's not hard. But what if we just got rid of all of the parentheses, right, and just went absolutely nuts doing the computation there, right, and moving everything to one side. So looking at this equation, it is no longer easy to see that the center is at negative 3, 1, and my radius is 49. Okay, this is called the general form of the equation of a circle. We don't like it. It's stupid. Okay, the reason why it's stupid is because in order to go from the general form to the standard form requires some work. And it's work that I warned you about. Man, I told you we're going to have to do this whenever we get to circles, and now we're here. Okay, so that didn't take long, did it? It took like a week and a half. But now we're here. But anyways, the general form of an equation is basically just, you know, everything on one side, basically. Everything on one side, and the parentheses gone. That's the general form of an equation of a circle. Okay, so now let's go ahead and try to tackle one of these problems. Okay, so this reads, write the equation x squared plus y squared minus 8x plus 6y plus 16 equals 0 in standard form. Okay, that's not good. Find the center, radius, and intercepts and sketch the graph. Okay, so let's go ahead and just start with let's go ahead and start with the hard part, transferring this over to my standard form. Okay, so in order to transfer this over to standard form, what we're going to have to do is we're going to actually color coordinate this. We're going to first put the x's, bunch the x's together, so x squared minus 8x. And we're going to bunch the y's together, so plus y squared plus 6y. And we're going to go ahead and put just a constant over on the right side. Okay, so I color coordinated these, and I don't want that in green, so let's try this again. Let's change the color. So what was x squared minus 8x. Okay, we're going to have to complete the square, okay, because if you recall, when we complete the square, we are able to turn something like this into a binomial, into something of this form. Ax plus b quantity squared. We're able to change it into something like that. And this is more in line with what we're looking for, isn't it? Because that would be our the center, finding the h and or k of a circle. Okay, so we're going to have to complete the square. So let's go ahead and start it. So the 0th step is b half quantity squared. The first step, I'm going to substitute the b, so I'm just going to leave that blank. The second step, I'm going to divide by 2, so I'm going to leave all that blank. And the third step, I'm going to square, so I'm going to leave the entire thing blank. Okay, so let's start with let's start with x squared minus 8x. Okay, well, what's my b value? What's a negative 8? So we're going to put negative 8 here. Negative 8 divided by 2 is a negative 4. Negative 4 squared is 16. Okay, so what I'm going to do, all right, is I'm going to add 16 to both sides. All right, so now this equation is going to turn into it's going to turn into x squared minus 8x plus 16 over here on the left side. Okay, and let's go ahead and write this over on the right side for right now. And let's leave a blank. And that's going to be minus 16. And then since we added 16 to the left, we're going to add 16 to the right. Okay. And before I erase everything on the right side of the screen, recall that in step 2, that's basically the factored form, right? So I can now change this into x minus 4 quantity squared. Okay, and then we're going to go ahead and put the plus here, and we're going to deal with the yellow now. Okay, so let's erase everything in my little algorithm over here. Okay, so we're going to deal with this number now. Okay, so 6y. So I divided my b is 6, so we're going to put 6 here. 6 divided by 2 is 3. 3 squared is 9. Okay, so we're going to essentially add 9 to this, to the left side. So if we add 9 to the left side, we must add 9 to the right side. Okay, and then again, the same procedure. I know in step 2, that's basically the factored form, so it's y plus 3. Right? And again, step 2, that's where I get this, and that's where I got the 4, or the minus 4 from the previous step. Okay. And then, well, I can honestly just kind of polish this off right now, right? So negative 16 plus 16 is 0, and then 9 is 9. So that's the steps to going from general form to standard form. Okay, so this makes it pretty darn easy. So now we have the center at, looks like a positive 4, negative 3, with a radius at 3. Okay, because again 9 is 3 squared. Okay, so we got the center, radius, and intercepts. No, we don't have the intercepts yet. So let's do the intercepts. So we're going to go ahead and snip this again and find the intercepts now. Okay, so again, the intercepts, realistically, I think it'd be easier if we just kept it in the standard form. Okay, but real quickly, let me see how the book will want it done to find the intercepts. Okay, so the book doesn't care, it looks like. Okay, so the reason, well, no, we'll transfer it from the equation here, because I bet that might be what they're wanting. Oh, can I just paste? Okay, so let's try this. I'm sure you can paste, but I don't feel like figuring it out and wasting your time right now. Excuse me. Alrighty, so we're trying to find the intercepts. So let's go ahead and start with the x-intercept. Okay, so the x-intercept is we set y equal to 0. So it will become x minus 4 quantity squared is equal to, and let's just go ahead and do the mental math here, right? If I set y equal to 0, I've got um, 0 plus 3 is 3. 3 squared is 9. We're going to subtract 9 from both sides, so we're going to have a 0 over here. Okay, we're gonna take the square root of both sides, so that's not hard. So it's just going to become x is equal to 4. Is that it? Yeah, that's it. Okay, so x is equal to 4. That is the x-intercept, so let's put that in green. And that's interesting, okay? So we only have one x-intercept, so what does that tell us? Well, it tells us that, well, we only touch the x-axis, touch or cross the x-axis in one place. And of course, we'll see that whenever we sketch this graph. And by sketching, I mean we're going to just copy-paste that. The y-intercept. Okay, so the y-intercept is, we set x equal to 0, so let's go ahead and again do a mental math here. So 0 minus 4 is a negative 4. Negative 4 squared is a 16. We subtract 16 from both sides, and I already see an issue here. So if we subtract the 16 from both sides, we're going to end up with a negative 7. Okay, so right away, as soon as I take the square root of both sides, we're going to see that we're going to end up with, you know, the square root of negative 7, which is going to give me an imaginary number. So this tells me right now that this has no y-intercepts. No y-intercepts. Okay, so let's go ahead and look at the graph. I don't have to snip all that. We'll do this. Okay, and of course we said our center was at 4, negative 3, that we do indeed see that happening, and we have the radius at 3, right? And that makes sense, right? So we're going up 3 units, right? So we're barely touching the x-axis, but we are indeed touching it at 4. But since we're, you know, going 4 units out to the right, we're not going to be touching any y-intercept, right? Because it takes 4 units to get to the y-intercept. So that also makes sense. So that's it. We wrote it. We went from general to standard. We found the center, we found the radius, and we found the intercepts. And that's that. That's how we do it. All right, and I'm pretty sure we got one more. I don't know how much more difficult it could be. It's the same thing, and we're going to do it, but it does seem like. I mean, maybe there's something here that's tricky. We'll see. Okay, because usually you don't do the exact same type of problem 2 times in a row. So anyways, write the equation in standard form. Okay, so let's go ahead and do that. Oh, well, I think I just found the tricky part. All right, so if you recall, in order to do the completing the square, we must have a 1 in front of the x squared, right? Well, in both these cases, we must have a 1 in front of the variable squared. In either of these cases, we have a 4. Okay, so what we need to do is we need to get rid of that 4 and turn it into a 1. So what we're going to do first is we're going to go ahead and divide the entire problem by 4. Okay, so this is going to be ridiculous. So x squared plus y squared. Okay, again, we divided by 4. So it's going to be plus x. It's going to be minus 2y. And it's going to be plus 1/4. It's equal to 0. Okay, so that's my new problem. Divided the entire problem by 4. No problem. All right, now we're going to go ahead and proceed like we did on the, so blue, yellow is what I did. So we're going to put all the x's, we're going to bunch the x's up, we're going to bunch the y's up, we're going to put the constant on the right side. So we're going to bunch the x's up, so we're going to have x squared plus x. We're going to bunch the y's up, so plus y squared minus 2y. That's going to be equal to a negative 1/4. Okay, so let's begin our completing the square process. B halves quantity squared. Step 1, we plug the b in. Step 2, we divide by 2. And step 3, we just do the squared. Okay, so first thing we're going to do is we're going to do the blue one, right? So the value of b there is 1, and that's pretty easy. It just becomes 1/1/2, and then becomes 1/2 squared, which is 1/4. Okay, so what we're going to do is we're going to skip the part where we add 1/4 to the left side. Okay, we're going to skip the writing of it, where we are still going to do it. We're just going to basically kind of skip doing, let's do a different color. We're going to skip this and jump straight to this. Okay, hopefully that makes sense. I mean, I know that I'm going to be adding to the left because I'm going to be adding to the right, but I also know I'm going to be adding to the left because I'm going to go ahead and write it in factored form. So this is what I mean by that. So I'm going to go ahead and make the left side over here x plus 1/2 quantity squared. Okay, so I'm going to go ahead and do that, and then I'm going to go ahead and also, okay, so I've got a negative 1/4 here. I'm going to go ahead and add 1/4 to the right side. Okay, so just a quick recap. Excuse me. What I'm doing is I did add 1/4 to the left side here, okay? Because that's the only way I can get this factored form, okay? But I'm just jumping straight to the factored form of that. That's it. And I guess that's the explanation. All right, well, we're done with that, aren't we? All right, next we're going to do the yellow. So let's erase all this. All right, so the yellow is a -2. So the value of my b is -2. So -2 divided by 2 is a -1. -1 squared is 1. So again, I'm going to jump straight to the factored form, being y minus 1 quantity squared. Okay, again, that's coming from step 2. And then I'm going to go ahead and add 1 to the right side, which is coming from step 3. Okay, and again, if that confused you, then you can just go back and look at example 5, how we did example 5. I'm just, I like efficiency. This is efficient, and we can get done a lot quicker and efficiently. So similar to the previous problem, all right, looks like we're going to have some canceling out over here. So let's go ahead and write this out completely. So x plus 1/2 quantity squared plus y minus 1 quantity squared is equal to, again, the negative 1/4 and positive 1/4, they cancel, so we get 1. So this means we have a center located at, probably shouldn't do that, probably, yeah, just trying to be consistent. Need to write these as colons. Makes it doesn't really matter. I don't know. All right, but anyways, my center is located at, it looks like -1/2 and a positive 1. And my radius, okay, again, r squared. Well, this is pretty easy. Well, what's the square root of 1 squared? Well, that's just 1. Okay. So we put it in standard form. We found the center and radius. Now we got to do the intercepts. And again, the intercepts are pretty easy. Same thing we have been doing. So let's go ahead and just snip this. And we're not even going to rewrite the problem, snip the problem. All right. So x-intercepts, we have to set y equal to 0. So we're going to have x plus 1/2 quantity squared. All right, and again, let's just do this mental math. If we set y equal to 0, we have 0 minus 1. Negative 1 squared is 1. We subtract 1 from both sides, so we end up with equal to 0. So we take square root of both sides, so we end up having an x-intercept at negative 1/2. Okay, so we're going to have one x-intercept this time, similar to last time. And then the y-intercept, we are going to set x equal to 0, so we're going to do some mental math. Although we're doing fractions now, so we're going to slow down a little bit on the mental math here. Okay, so we're going to go ahead and just take this one a little bit slower, because nobody likes fractions, and everybody wants to see how you do fractions. Okay, so how do we do this fraction? Well, 1/2 squared becomes 1 squared over 2 squared, so it becomes 1/4, right? So 1/4 and then plus y minus 1 quantity squared is equal to 1. We're going to subtract 1/4 from both sides, so we're going to end up with y minus 1 quantity squared is equal to 3/4. Okay, and then we do the square. We take the square root of both sides, and then we're going to add 1, so we're going to end up with y. And let's do this. Let's put it in green. We're going to end up with y is equal to 1 plus or minus the square root of 3/4. And we're going to go back and make this green as well. Negative 1/2. Okay. And then it wants us to sketch the graph, but as always, not me. There, just like that. And of course, we need to see our x-intercept at negative 1/2. We see our y-intercept at, they rationalize the denominator. Pretty sure you can put it in as a decimal, but if you can't, let's go ahead and fix this up, because, you know, we like to remember how to rationalize denominators. So let's rationalize this denominator real quick. So the square root of 3/4 is the same thing as saying the square root of 3 over the square root of 4. Right? Oh, well, actually, there's I take it back. There's no rationalizing at all. It's just simply rewriting, right? Because the square root of 4 is easy. That's 2. So we have the square root of 3 over 2, which is indeed what we see up here. So yeah, no need to rationalize. That takes care of that, and I believe that concludes. Yes, that concludes today's lecture.